Welcome back, Professor Loeb. It's always an honor to have you on the show, especially after our last four episodes with you were such a super hit.
Thank you.
And that shows how much people love listening to you, and knowledge you have is just so wonderful. So thank you so much for being here.
Thank you.
Your passion shows in the fact that you write all these Medium blogs. I actually was able to read through most of them, and my questions are based off of that as well.
Mhm.
And it's wonderful how you're able to, with all your work, write those. So, Professor, you have framed Three Eye Atlas as a kind of a Turing test. I want to know if this were a test from a superior intelligence, what behaviors, ours or the objects, would constitute passing versus feeling?
Right. First, I should say I'm seeking a higher intelligence from interstellar space because I don't often find it in academia. Um, and in terms of a Turing test, it's possible that they're checking us. Okay, so they could even send a rock in our direction to see how we respond to the fact that it's coming in a very special trajectory that will pass near planets, because then they would be able to gauge from our response how intelligent we are, how sophisticated we are, what do we do about that. So we just don't know. And I think from our perspective, we should just collect as much data as possible. And in the future, there should be an organization, a committee that is coordinating the assembly of data from all space assets, from all observatories on Earth, and then analyzing it, asking, is there any anomaly that looks suspicious? And of course, it would show a sign of intelligence on our side if we were to recognize the difference between a spacecraft and a rock. If we go back in history, more than 100 years back, obviously humans were not able to tell the difference or not even detect such a thing. And in fact, if you go 400 years back, then the Vatican insisted that Earth is at the center of the universe. And now we have cameras on board orbiters around Mars, not around Earth, around Mars, another planet, that are observing an object that came from outside the solar system. That's amazing. So we made some progress, but we are still reluctant to consider the possibility that we are not alone seriously. And I say that because the mainstream of the astronomy community is willing to invest more than $10 billion over the next 2 decades in the search for microbes, the chemical fingerprints of microbes in the atmospheres of exoplanets. And while this is certainly likely to be there, the microbes might be very abundant, their signatures are very subtle. So it's just like being at your home in, the Earth, and looking out at the cosmic street and seeing many analogs of the Earth-Sun system, many analogs of your home on the street. And my colleagues are insisted these houses on the street must have microbes in them. So to detect those microbes from a distance, you need to build a very powerful telescope. It's called the Habitable World Observatory, in order to see those microbes at the vantage point of your home. But instead, if you imagine that one of these houses has a resident, the resident might show up at your front door, or you might find a tennis ball in your backyard that was thrown by this resident, or you might see some construction in the backyard of that resident, and you could see it from a distance much more easily. So my point is, we should hedge our bets and put billions of dollars not only to the search for microbes, but also to the search for intelligence at the same time. The public definitely cares a lot about it. The public funds science. So it makes a lot of sense for us to do both at the same time, because the prospects for detection might be bigger. And if we're looking for technological signature. And in the past, we were just waiting for a phone call, a radio signal that comes from thousands of light years away. But now we have the opportunity to look for objects that entered our backyard. So we should check our mailbox. We should check our backyard if everything is rocks or something else. And Three Eye Atlas is a good reminder that there could be surprises.
Right, definitely. So if scientists eventually at some point start to become confident that an interstellar visitor wasn't natural, likely a device from another civilization, should we stay quiet and just observe it and make scientific observations, or should we try to send it a message? And if you favor messaging, what type of messaging do you think that should be?
Yeah, that's an excellent question, and it depends on the characteristics of the visitor. When you have a visitor to your backyard, you have to watch the visitor and decide how to respond to that visitor. It depends on the intent of the visitor. You know, it could be a friendly visitor, in which case you can engage in a conversation. And so, just to give you an example, here at my home, there was once a person standing on the street and looking at my home for about half an hour. And my wife said, well, it looks suspicious. Would you mind checking what's going on? And I went to him and said, why are you staring at our home? And he said, oh, I used to live at this home 50 years ago as a kid. And we buried a cat in your backyard, and I want to see it. And I said, what was the name of the cat? And he said, Tiger. And I said, well, that sounds familiar because I saw a tombstone with Tiger written on it. So the lesson from this was a friendly visitor, not a hostile one. And I learned something new because I was worried that tiger means that there is a tiger buried under this tombstone. And turns out it was a cat 50 years ago. So it's possible that there were civilizations in our neighborhood. For a while, they know much more about the history of the solar system and about our past, maybe even what happened before the Big Bang, maybe even how much life forms exist in the Milky Way galaxy, all kinds of things we don't have a clue about, including the dark matter, including dark energy, and all kinds of things. So by engaging with them, we might learn those things or learn about new technologies. So there is a benefit to engaging with a friendly visitor. However, it could also be a Trojan horse, a hostile visitor that looks friendly at first, but then turns out. So we should assess the threat, the level of threat. If it looks like we could benefit from an engagement, then I suggest starting with a sentence welcome to our cosmic neighborhood, peace, offering them peace. And of course, the question is in what language, how do you actually communicate with something that is from another star? They may think differently, they may be much smarter than us. So it's like the experience might be similar to ants in the crack of a pavement, looking at a biker that passes by and trying to say something to the biker. The biker doesn't care about them because they are completely insignificant. So we might be just like those ants trying to converse with something superior to us. But at the very least, we should watch it and learn about it. If it approaches Earth and poses a threat, we need to decide what to do about it. We might not be able to do much because our technology is inferior. But at the very least, we should be aware of that. So, and there should be a discussion of all humans because it's an international security issue. It's not, the aliens don't care how we split the land on this rock that we live on, the Earth. So all of us are in the same boat. And if one of us rocks the boat, all of us may sink. So there needs to be some international cooperation and agreement about how to engage with such a thing. And if someone violates that agreement, that someone should be punished because it affects all of humanity. So all of these rules or decision of how to respond to a visitor were not put into writing in any document. There is no procedure, protocol, how to deal with an alien technological visitor. And so I think we should start this conversation. And that's why I wrote a white paper to the United Nations. But I don't expect them to respond. I don't expect the politicians to attend to this. Even though in a recent interview, immediately after my interview, a policy advisor to President Trump was asked whether the president is made aware of 3i Atlas, and the answer was that he is aware of any important development, and they're not worried about any impending threat or any issue. So eventually, I think the Congress or the White House will need to develop some kind of a protocol how to deal with a black swan event that has to do with an alien technology.
Mm-hmm. It's quite interesting. There is something I was reading about called the dark forest
Right.
idea. So I believe it basically says that advanced civilizations avoid drawing attention. My question is that if 3i Atlas turned out to be artificial yet noticeable, would that contradict the dark forest view or suggest like a different strategy that they might be using? So I was just wondering, what interpretation do you find of that?
Right. So the dark forest is the idea that aliens might be close to us, but they are silent. We don't know about them because in a dark forest, you worry about predators and you don't want to be noticed. You just want to observe any potential threats. And if they were observing us for a while, because we transmitted radio signals for more than a century now, perhaps they decided to do a reconnaissance mission where they would collect more data or figure out what happens in the inner solar system, in which case, they would send something that looks completely natural, like a comet that has some devices inside of it. I mean, you can easily bury some technological gadgets that we would not be able to tell, and then send it on a path that would be coming close to the targets that you're interested in. And also, you can imagine putting gadgets that will be released when the object gets close to the sun, and eventually smaller objects that do not require as much power will maneuver towards the targets of interest. And so we should check for that. We should check whether 3i Atlas is, for example, fragmenting or losing, there are additional dots of light around it that travel to the planets, like the Earth or Mars. We should check for that. So in that case, you can imagine a reconnaissance mission, meaning they want to gather some information, and that could not be a hostile, act, but it could be a precursor to something that will come later. And they may do that on a routine basis, especially if they realize that we are developing our technologies. Now we develop AI. We had nuclear weapons not so long ago, developed over the past century. And they just want to catch up with what's happening. Of course, there is... So if we were able to recognize it's technological, then they would, of course... they would not achieve their goal. They would prefer us not to notice their existence. When it comes to them attacking us or threatening our future, then it would be a much more serious matter. As you say, we would notice it, but maybe too late, or maybe it would be devices that we have no way of coping with because they are so much superior to what we can protect against. So far, Congress tasked NASA to protect the Earth. It's called Planetary Defense, to protect the Earth from objects bigger than a football field, 140 meters, that may collide with Earth, because we know that the dinosaurs were killed by an asteroid the size of Manhattan Island 66 million years ago. We are smarter than dinosaurs. We can trace objects bigger than 140 meters, much smaller than the one that killed the dinosaurs. So we want to perhaps deflect any such object that may collide with Earth. So that's why we started discovering these interstellar objects, because NASA and the National Science Foundation and the Department of Energy invested in observatories like Pan-STARRS in Hawaii or the Rubin Observatory in Chile to look for near-Earth objects. And in the process of monitoring the sky, they are finding interstellar objects. So the reason we know about interstellar objects is just because of that. But if you think about a rock hitting the Earth, that's the most primitive form of object that you can potentially predict the trajectory of if you know its parameters, based on the law of gravity, based on if it's a comet, you can also see how much mass is being lost. But if it's a technological object, all bets are off, because it can decide to maneuver or move in ways that you cannot forecast. And That kind of a threat was never discussed.
Mhm. That's quite interesting. My question to you, Professor, is that if an interstellar object was trying to hide, what are some unavoidable leaks that might still give it away, do you think? And some of the ones that I was thinking of was extra heat, a polarizing glow, plasma wake, things like that, or strange flickers, maybe. And I was wondering what instruments are being used or are you planning to use to look for these?
Right. So the ultimate stealth object that I can think of would not be visible. It will not reflect sunlight. You won't be able to detect it with a radar system. Um, and, for example, we know that most of the matter in the universe is dark. We don't see it. It's called dark matter. So suppose a more advanced civilization figured out what dark matter is and they can engineer it, make a spacecraft made of dark matter. We would never be able to see it because we can't see dark matter. So most of 85% of the matter in the universe is dark matter. So if they have a way of engineering a spacecraft made of dark matter, we would never see it. But of course, you can also imagine a spacecraft made of matter that reflects very little sunlight and has a small signature, or one that moves really fast, close to the speed of light, a fraction of the speed of light. We won't see that in our telescope images because an object moving close to the speed of light would be smeared into a streak on any image that we get with telescopes that have some finite exposure time. And these streaks would be very faint and also indistinguishable from other noise. So astronomers would just completely ignore a streak in their images from an object moving close to the speed of light. So that's a way to basically avoid any detection. And we just don't know. We can only monitor objects moving at speeds of the order tens of kilometers per second, the speeds of planets or asteroids or comets that we find in the solar system. That's the kind of alert system that we have. And if something, and that's just one part in 10,000 of the speed of light, very small, a percent of the speed of light. So if something moves at orders of magnitude faster than a percent of the speed of light, we won't be able to notice it because it will be smeared in our images. However, something moving very fast that is very massive, even if it's made of dark matter, we should be able to detect. And I actually wrote a paper about it because any object, it generates a gravitational signal. Any object generates gravity. You can't avoid that, any concentration of mass. So if we notice a pulse of a gravitational signal as a result of an object passing near Earth, we would definitely know that something dark is passing if it's quite massive. And I actually calculated that the LIGO Observatory for Gravitational Waves can set limits on objects that are, of order 100 billion tons, passing close to the speed of light near Earth. They would have been detected by the LIGO Gravitational Wave Observatory. However, maybe they don't exist, objects that move so fast. But in the future, if we build a network of gravitational wave detectors that are very sensitive even to low frequencies, not like LIGO, sensitive to 100 hertz, but something that is even at the frequencies of millihertz, that is extremely sensitive, we should be able to see passing objects through their gravitational signal without detecting any light reflected from them or emitted by them. And that would open a new window into dark objects that are massive, passing through the solar system we've never seen before. And so I'm saying, in principle, when we develop gravitational wave observatories that are very sensitive, we will see everything passing through the inner solar system, irrespective of how faint these things are. The aliens will not be able to escape detection at that point. But right now, they can easily escape detection.
That is so much information to digest. Thank you so much, first of all, for sharing all of this.
I should tell you that in 2 weeks, I'm going to California to a NASCAR car race because one of the drivers in that race of NASCAR, wrote to me a message saying that he wants to put 3i Atlas and my image on the hood of his car. And I explained to him that his car will not move faster than a factor of 600 slower than 3i Atlas, because 3i Atlas is moving at 60 to 68 kilometers per second, and even the fastest race car is 600 times slower than that. And so, nevertheless, he was not deterred by that statistic, and in 2 weeks, we'll see if his car wins the race. But in the cosmic scheme of things, car racers are really not moving really fast. They're quite slow.
Wow, but that's so amazing that he reached out to you. It's like such a different industry.
Exactly. It's a different mindset. And there was a musician from England that just a week ago wrote to me that he made a song that reflects extraterrestrials. And then there is a sculptor from New York City that is a very accomplished sculptor, Greg Wyatt, and he decided to donate 50 watercolors and 2 sculptures of Galileo Galilei that he made to my office. So I will be able to fundraise by charging. My office will become a museum.
Oh my goodness.
In about a month, and we will celebrate his gift in a special event. There will be music composed by a composer for that event. And so I'm really amazed that the artists and also car racers find it inspiring. But most important for me is that young adults are attracted to science when they hear about the process of scientific discovery, how exciting it could be, and how impactful it might be if we discover aliens, for example.
That's so interesting. Actually, just right now, I was attending a Harvard conference and presenting a paper there, and Sunita Williams is from NASA is actually giving a talk right now on the convergence of space science and spirituality. So it's wonderful how these fields are.
Yeah, I mean the common theme of spirituality and scientific work at the frontier is that they both explore the unknown, and the way to explore the unknown is with a sense of humility. If you think you know the answers in advance, and if you are arrogant, you will not discover anything new, because you will basically live in an echo chamber. Unfortunately, that's where most academics are, because they build their own echo chamber and they get their stature and self-esteem out of being an expert. What does it mean to be an expert? It means that you pretty much can tell people what you know, and that will explain everything that they see. That's the meaning of an expert. If you see something you've never realized before, then your expertise is irrelevant. This is something new. Everyone can learn it. So experts very often resist something new, because then it puts in doubt their knowledge, their stature, and they want to explain everything they see with what they already know. So when, for example, Oumuamua, this first interstellar object, was discovered, they argued it's a comet. Then it was realized there is no cometary evaporation around it, no gas, no dust. The Spitzer Space Telescope looked very deep and couldn't see anything around it. So now they call it a dark comet. And to me, it sounds like someone who is an expert on zebras going to the zoo and seeing an elephant and then saying the elephant is a zebra without stripes. And, that obviously reflects their expertise. So they classify the elephant as a zebra, but, just a little different from a zebra. They don't realize it's a different animal. So spacecraft, for example, are not comets, because they can be they can maneuver or exhibit non-gravitational accelerations that have nothing to do with gravity, and therefore you can't know for sure. When you see an object that doesn't have any cometary evaporation, that is not pushed by being evaporated, you can't tell whether it's a technological object or maybe something anomalous that nature made, but
Yeah.
you should definitely not call it a dark comet the way they do. It's a cheat. And, I prefer to stick with my mindset when I was a child. I hated this idea that the adults in the room are telling me stories that do not make sense. I want to figure it out. So I want to be with an open mind. And many people that knew me as a kid, they would say I stayed the same thing. And science is really a privilege of maintaining your childhood curiosity. It's really a gift, a privilege. Having tenure in academia allows you to take risks, to think about ideas that may turn out to be wrong, but on the other hand, they might be extremely impactful. So think about what is called in the intelligence agencies a black swan event. What it means is the intelligence agencies are considering events that have a very low probability of being realized. Why do they do that? Because those events could have a huge impact sometimes. So an example is the October 7th event. The Israeli intelligence agencies did not imagine something like that. They completely dismissed it, and the implications were huge afterwards. And so as a result, even people who are down to earth, very worried about political events, military events, they always contemplate ideas that have a low probability but would be very impactful. And it goes back to Blaise Pascal, the philosopher mathematician, who said we must discuss God. Why? Because even if you think the probability that God exists is very small, the implications are huge. Therefore, we cannot ignore this subject. So I say the same thing about the possibility that an object entering the solar system that looks anomalous might be technological. You might argue the probability is small, but I say the implications are huge. Therefore, we must discuss it. My colleagues are saying the probability is small, therefore we should not discuss it. If my colleagues were in the intelligence agencies, they would have missed on many, events that ended up being catastrophic because they would never contemplate that they're missing something.
Right. And the three things I love, you said courage, humility, and curiosity, which you've had. And definitely in science, one thing leads to another. So it's whatever discovery you're trying to make, obviously it has so many implications going forward in the future.
Right. But you might wonder, why is it rare? So why isn't that common practice? And the answer is because if you take risks, if you imagine things that are not known and you're willing to consider them, then there is a chance that you will be wrong. And then you are putting at risk your future career, the respect from your peers. But if your objective is not to get as many likes as possible, if your objective is not to win prizes, because what are prizes? The awards given by human students. If your objective is to understand nature, then who cares about these other things? We live for of older 100 years, and I see many of the most distinguished scientists that at the time got as much respect as they wanted from their colleagues being forgotten. After they die, even their students don't talk much about them. So all of this effort to get appreciation, awards, honors, they're completely irrelevant. What should give you joy is the process of understanding nature, trying to figure it out. It's like a puzzle, and you have some clues. It's a detective story trying to figure it out. That by itself is the purpose or the joy that you can draw from the scientific work, and being paid for that is an extra bonus. Having tenure means that you can entertain ideas that might turn out to be wrong. That's the whole point about job security.
Right.
So people who get tenure then don't completely forget about the purpose of being tenured as a way of exploring ideas that are not within the beaten path, and they not only do that but ridicule and push back against anyone that tries to do that. They feel threatened by someone who is suggesting that not everything in the sky is rocks. And if you think about it, that makes no sense, because we launched spacecraft. We know that we polluted space with technological objects. So why should we assume that we are unique and special and the only ones in the universe? Like, there could have been others. Most stars formed hundreds, of millions to billions of years before the sun. So there was plenty of time for their Voyager spacecraft to reach our backyard. It takes less than 1 billion years for a spacecraft like Voyager, the same technology that we used in the 60s, to go across the Milky Way galaxy. There was plenty of time for even low-level technologies to reach our backyard. So we should just watch out. We don't know how much traffic of technological debris there is in our cosmic neighborhood. So we should just check what is going on. And of course, it's the way I see it is like a blind date. You don't know who will come your way. And, if the other side ends up being a rock, it might be disappointing, boring. But, if it's a product of an intelligent civilization, then we can learn from it. It would have a huge inspirational effect on our future. And of course, it could also be that the other side would be a serial killer, and that we should worry about as well.
You don't know how many comments we get on our podcast with you. People are just so curious and they have like a million questions. So this is going to be very helpful for them. Please continue to write your Medium blogs because it helps so many people, and we keep sharing them in our description as well. And it was an honor to sit here with you today.
Oh, thank you so much for having me. And of course, we have an infinite number of questions that we don't know the answer to. That's why young people have a place in science to figure out the answers that we don't know. And frankly, I would have loved to live for a long time because there is so much work to be done. And the only way by which we can address all these questions, given that we have a finite life, is by young people getting engaged and finding answers that we don't know right now. So I'm really delighted that the opportunity to speak with you and younger people, so that you can carry the torch forward and answer questions to which we don't have the answer right now in a way that would surprise me, actually.
That's what we aim to do. Thank you so much.
Thank you.
Professor Loeb, it's great to have you back on the show.
Thanks for having me.
Of course. Last time we spoke, we had such an amazing conversation about 3I Atlas, and your insights really resonated with so many of our listeners. I'm excited to dive deeper into what's happened since, especially with all the new findings and ideas that have emerged. I know our audience is eager to hear what's next, so welcome back, and let's just jump straight in.
Yeah, so we still don't know the size of this object. That would be the most exciting constraint that we can get, because initially, based on its brightness, it appeared to be the size of tens of kilometers, somewhere between maybe a few kilometers up to maybe 46 kilometers, based on the amount of light that was reflected from it. But some of this light could have been reflected by ices or dust surrounding it. So the best image we got of 3I Atlas was obtained on the 21st of July, 2025. And that showed a jet of scattered light towards the sun, 10 times longer than it is wide. We watched it roughly from the same direction as the axis connecting the object to the sun, within only 10 degrees away from that. And it already looked as if it's elongated towards the sun. So if you correct for the viewing angle, you find that this jet of luminosity was pointed towards the sun and was 10 times longer than it is wide. And that's surprising, because usually sunlight is scattered by dust particles that are getting pushed away from the sun by the radiation pressure. And in this case, we saw scattered light ahead of the object towards the sun rather than behind the object. So it was an anti-tail. And the question is, what's the physics behind it? What is the origin of this anti-tail? That continued to exist for July and August. And then at the end of August, there was a faint tail stretched behind the object. And then on October 3rd, 3I Atlas came closest to Mars at a distance of 29 million kilometers. And that was the best opportunity for us to get a better image than was obtained by the Hubble telescope. And indeed, several of the Mars orbiters were looking at it, and the European Space Agency released a preliminary image or images that were taken by a camera on board the ExoMars orbiter. And unfortunately, that camera had an aperture with an area that is 300 times smaller than the Hubble telescope mirror. So it basically verified roughly the same images we saw from the Hubble Space Telescope. It identified the luminous core of the object, but couldn't really go to the periphery of that region to tell us what is happening. Just rough analysis of that image implied that there was no significant major change in the activity of the object, in the amount of mass loss. But the object appears to be quite big. And in fact, I did a calculation that suggested that it's at least 5 kilometers in diameter. And the calculation was as follows. We see mass being lost from the object, especially from the side facing the sun. And that should give a recoil to the object, push it away from the sun, unless it's very massive. So I looked at more than 4,000 data points that were describing the motion of the object across the sky over the past 5 months. And those were obtained by 227 observatories around the world. And amazingly, the object was following exactly the trajectory that is sculpted by gravity alone, that one would expect it to follow, despite the fact that it was losing mass. That implied that it's very massive, at least 30 billion tons. And if you assume solid density typical of comets, you get a diameter which is at least 5 kilometers. So we don't know how big it is. It's at least 1,000 times more massive than the previous interstellar comet, Borisov, that was discovered in 2019, and perhaps more than 1 million times more massive than the first interstellar object, Oumuamua. And that by itself is an anomaly, because we would expect to find millions of Oumuamua-like objects before we see one giant one as big as we infer for 3I Atlas. And moreover, there is not enough rocky material in interstellar space to supply such a giant rock every decade. And so we would expect such a big rock to arrive perhaps once per 10,000 years or longer, but we found it over a survey that lasted less than a decade. And so that is a big anomaly, as far as I'm concerned, the biggest one. And then, of course, this object 3I Atlas is lying on the plane of the planets around the sun. Its trajectory is aligned with the ecliptic plane to within 5 degrees. And the chance of that happening at random is 1 in 500. And in addition, observatories on Earth identified the composition of the gas plume around it. So the Webb telescope implied, together with the Spherex Space Observatory, implied that the gas is mostly made of carbon dioxide, 87%. Then about 9% is carbon monoxide, and then 4% is water. And that's very unusual. But more remarkably, nickel was identified with very little iron. And usually nickel and iron come together in comets. The only place where we find mostly nickel is in industrially produced nickel alloys. And that raises the possibility that maybe the surface of this object was manufactured artificially. That is an anomaly that needs to be explained. So when people say it must be a comet, or they call it a comet, they need to be held accountable to explaining those anomalies. There needs to be an explanation. Now, I divide the anomalies into 2 parts. There are anomalies that we may understand as we get more data. For example, the composition, we might figure out where it came from, or the size, we might realize that it may be smaller, or that there is a reason why it's so massive, because it's actually not a rock, it's an object that was made under unusual circumstances. But there are some anomalies that will never go away. like the alignment with the plane of the planets around the sun. Why is it fine-tuned to be in that plane? And also the arrival time of this object is fine-tuned so that it came close to Mars on October 3rd, and it will come close to Jupiter on March 16th. And the timing has nothing to do with the trajectory being aligned with the planets. It has to do with the fact that these planets are orbiting the sun. So for them to be at the right place at the right time, the object needs to come at the right time. And the chance of that, I calculated, is 1 in 20,000. So there are all these small probabilities. And if you combine them, it means that the probability of having an object as rare as 3I Atlas is 1 in a million or less. And it means that it's a gift to us, even if it's natural in origin. It's very unusual in the sense that it's big and therefore bright, so we can observe it easily, but also it comes close to places where we have orbiters or space assets that can observe it. So it comes close to Mars, and we can use our own cameras to look at it. Most importantly, NASA has had the high-rise camera looking at it on October 2nd with a pixel resolution of 30 kilometers. So it can set the brightest pixel in that image, can set the best constraint on the size of the object. However, there is a government shutdown, and therefore the NASA data was not released.
Oh.
And we're waiting for it. Hopefully, in the coming weeks, it will be released. Some people suggested a conspiracy. They argued that maybe it's a signature that the government knows of some flags of extraterrestrial intelligence. And I argue that it's unlikely to be a signature of extraterrestrial intelligence. This delay in the release of data is more likely to be a sign of terrestrial stupidity.
Well, thank you so much for sharing. That answers so many questions that our audience already must be having. And you mentioned this a little bit earlier, but I would love for you to elaborate on this. Is the bright halo around 3I Atlas a real dust cloud or just an imaging artifact? And what one observation would settle it, given limits from sublimation, radiation pressure, and dust charging?
Right. So we don't have a direct evidence that there is dust around it, because dust would have been pushed behind the object by radiation pressure. It's not destroyed by the radiation. So one possibility is that this bright jet pointed towards the sun is a result of the release of ice fragments from the sun-facing side of the object, and those ice fragments get eventually evaporated, so you don't see them behind the object. By the time they turn around, they are already gone. So that's a possibility for explaining why it's leading the object, this glow that we see. Now, more recently, there was a slight evidence for some weak tail behind it, and perhaps now we also see the evidence for dust, but we don't have enough data on that. And so the question is how to explain all these unusual characteristics and also the composition of the object. And that is still unresolved. And I hope that in the future, more studies will be dedicated to that. I wrote a paper with a colleague, Eric Kito, trying to explain this elongated bright jet ahead of the object towards the sun. And we try to explain it in terms of fragments of ice that are being evaporated. And we managed to get most of the features this way.
Oh. Would you say that discovery bias is being made and interstellar objects appear unusually bright or odd, meaning 3I Atlas looks anomalous mostly because that's what we're capable of detecting?
No, because we detected previous interstellar objects. They were Oumuamua in 2017 and Borisov, which was a comet, in 2019. Now, a comet is usually easier to detect because in addition to the nucleus, there is a cloud of dust and gas that you can see in reflection of sunlight. So effectively, you get more reflection than from just a solid rock. However, we were able to detect Oumuamua, which was only 100 meters in effective size. And Borisov was more likely a few times bigger, but nevertheless, both of them are a factor of at least 10 to 100 smaller than 3I Atlas, meaning that we can detect smaller objects. It's just that this one showed up, and it's sort of a blessing in disguise because we can observe it more easily, but then we realize that we don't fully understand it. So I think, like in any blind date, and this one is of interstellar proportions, the best approach is to observe the other side, not to have an opinion to start with. And many comet experts immediately said, well, it's a water-rich comet of the type that you would expect from old stars because it came from potentially the thick disk of the Milky Way galaxy. But to me, the most striking fact is that the disk of the Milky Way galaxy is misaligned. It's tilted relative to the ecliptic plane of the planets around the sun by 60 degrees. So if you say, well, most objects should come from the direction of the disk, you would get objects coming at 60 degrees relative to the ecliptic plane. However, this one came just along the ecliptic, and for the third object to be so aligned with the ecliptic, when the chance is 1 in 500, that's very surprising. And then having a mass of at least 33 billion tons is also very surprising. So I'm still struck by those. And 2 months ago, I defined a new scale that is now called the Loeb scale for classifying interstellar objects. And 0 is the rank of a natural object that came from a natural origin, like a regular comet or an asteroid, a rock. And 10 implies a technological object that could be a threat to humanity. Right. And I initially ranked 3I Atlas as 4, and I still hold to that, somewhere between 3 and 4. Most likely it's natural, but there is a significant possibility given the anomalies. It has 7 anomalies. I didn't mention all of them. One of them, for example, it has a very large negative polarization for the light coming from it, never seen before for comets. It's also it arrived from the same direction as a radio signal that was discovered in 1977. 2 weeks ago, I realized there is this wow signal that was found in 1977, August 15th, by the Big Ear Observatory at Ohio State University. And the observer that wrote down the lab notes wrote wow next to this signal because it was very bright relative to the noise. And it was definitely extraterrestrial. And it was very close to the frequency of hydrogen hyperfine transition. And it was emitted by a source that was moving towards the sun. Now, I checked the direction from where it came, and within 9 degrees, it came from the same direction as 3I Atlas was 1977. Oh, and back then, 3I Atlas was at a distance of 600 times the Earth-Sun separation, about 3 light days away. And if this signal was produced by 3I Atlas, then the power emitted should have been of order a gigawatt, which is the power you get from a nuclear reactor on Earth. So if it's a big spaceship, definitely can have this power. The question is, and it was also moving towards the sun, like the source of this object. The chance of a random alignment of these 2 directions is 0.6%. So I urged radio astronomers to look at the object and check whether it's emitting any radio signal at this frequency right now. So far, nobody reported about radio observations of this object. You see, many times observers miss an opportunity to discover something new by assuming that there shouldn't be anything interesting. Just to give you an example, I once realized that was a decade ago in a paper that you can distinguish an artificial source of light from a typical asteroid that reflects sunlight. And the way to do that is, if it reflects sunlight, the farther it goes, the less amount of sunlight is impinging on its surface. And so the amount of sunlight declines as inversely with distance squared from the sun. But then the amount of the flux that we detect from that object has another factor of 1 over distance squared. So altogether, you have a dependence as 1 over distance to the 4th power. Whereas if the object emits its own light, if it's like a light bulb, then the flux will decline only as 1 over distance squared. So just by plotting how the flux of objects in the outer solar system, like in the Kuiper belt, changes with separation from the sun, you can infer whether it's an artificial source of light or it's just reflecting sunlight. So I had one of the leading astronomers who discovered many of the Kuiper belt objects in my office. And I asked him, did you check whether the flux varies inversely with distance squared or distance to the 4th? And he said, why should I check? It must be 1 over distance to the 4th. So this is just to illustrate how observers miss opportunities to discover things. There is another example of Otto Struve, an astronomer that in 1952 suggested to look for hot Jupiters. These are Jupiter-like planets that are close to a sun-like star. And he was ignored because people said, we know why Jupiter is so far from the sun. That's the region where water ice forms, and Jupiter was made as a result of this process. And therefore, there is no reason to waste telescope time and look for Jupiters that are close to their parent star. And guess what? 43 years later, 1995, there were 2 people who got some telescope time to check that and discovered a hot Jupiter near a sun-like star. And these were Didier Queloz and Jeff Marcy, and they received the Nobel Prize for that discovery. And the problem is that there were 4 decades wasted of people not checking whether they're prejudiced, that there shouldn't be such a system is true or not. And it doesn't require a significant amount of resources. You just need to allocate, let's say, 10%, 20% of telescope time to check what you believe in and verify that it's real. A Nobel Prize-worthy discovery was waiting for 4 decades because of that. And in fact, the discovery paper didn't even cite Otto Struve because his contribution was perhaps forgotten by the time that the discovery was made. So it shows you that science is very often inefficient because the practitioners of science, the scientists, have a prejudice that prevents them from embarking on new paths that were not taken. And I argue the same about, for example, 3I Atlas or interstellar objects. Of course, it may most likely be just natural, a comet, but we should check because it may not be that.
No, exactly. I totally agree with you. And you mentioned this a little bit before, but ideas like 3I Atlas being made of antimatter, what clear signals, gamma X-rays, or annihilation lines would make you take that seriously or rule it out?
Right. So, in principle, the best fuel for propelling an object would be antimatter because it converts the rest mass energy of matter into pure radiation. So it's the cleanest source of energy. With nuclear reactions, you end up getting at most 1% or a few percent of the rest mass converted to energy. And chemical energy production is much less efficient. It's of the order of 1 part in 100 million of the rest mass converted to energy, including in explosives. So indeed, annihilation, taking antimatter and combining it with matter is the best fuel, most efficient fuel for getting energy. The problem is that antimatter was not left from the Big Bang. It was all annihilated, and we have a little bit of excess of matter relative to antimatter in the initial conditions of the universe that allowed us to exist. So there was a residue of matter, 1 part in a billion excess of matter relative to antimatter. So all the antimatter disappeared from the universe because it was dense and hot early on. And then matter, a little bit of excess matter stayed around, and that's what we are made of. So the bottom line is there is not much antimatter to be found. And therefore, the only way is to produce it artificially. And CERN is producing antimatter in colliders, but just about a nanogram of antimatter is as expensive as 10 kilograms of gold or something. So it's just extremely expensive to make antimatter. And therefore, perhaps, alien technologies were able to do that, but it's unlikely that such antimatter is being used. However, if an object comes along and it's made of antimatter, you would expect, as it comes in contact with, for example, the gas in the solar system, there is a wind coming from the sun that would impact on it. You would expect some annihilation and gamma rays coming out of those annihilation products, and therefore we should be able to detect gamma rays or X-rays. And there are telescopes, for example, the Fermi Gamma Ray Telescope or the Chandra X-ray Observatory, that potentially could detect these signals. So haven't heard about any results from those telescopes, any data on 3I Atlas, but it would be worthwhile checking just to be sure that there is nothing anomalous with this object.
Yeah, no, it definitely would be worthwhile checking. Professor, if 3I Atlas were technological, what operational behaviors would we look for? For example, course correction, controlled spin states, and how could current assets detect them?
Right. So how to distinguish a spacecraft from a rock? There are several ways. If it maneuvers, then beyond the level that you expect from cometary evaporation, it means that there is some propulsion system, some engine that allows it to maneuver. And the best point for an object to maneuver is at closest approach to the sun, because then you get the benefit of gravitational assist from the sun. The sun is accelerating the object, and if you power your engines at that time, you can either slow down or speed up. And usually that's what we do with our spacecraft. If we want to launch them to the highest speed, we send them closer to the sun, and then when they are close, they get the gravitational assist from the sun. And if 3I Atlas will do such a maneuver when it comes closest to the sun on October 29th, that would be extremely surprising for a natural object, given that so far we haven't detected any deviation from a trajectory sculpted by gravity. So it showed negligible non-gravitational acceleration. If suddenly it changes course and we don't see an enormous eruption of evaporated materials or breaking up of the object, then this would be a very clear technological signature. And as a result, the financial markets may collapse because there might be a threat to humanity here on Earth. So we have to wait and see. But an additional signature of a technological object would be some artificial light or excess heat that goes beyond the amount of sunlight impinging on the object. And of course, if we detect a radio signal, like I mentioned before, that definitely will say that it's technological, because we don't expect a radio signal, especially at the frequency, a narrowband frequency of hydrogen, to come from a comet.
Wow. And you mentioned this a little bit before, but I would love for you to confirm for our audience that is viewing this video right now that the approx 5-degree tilt between 3I Atlas's orbital plane and the ecliptic, it's very statistically odd. Am I right?
Right. It's 1 in 500, taking account of the retrograde trajectory that it took. If you allow both for prograde and retrograde orbits, maybe you get twice that probability. So it's 1 in 250 chance.
Wow.
But this is the third object. So that means we have a discrepancy by at least a factor of 100. In other words, we should have seen 100 objects before one of them, by chance, would have been aligned. And indeed, the first two objects, Oumuamua and Borisov, had a very large angle relative to the ecliptic. There is no reason why they should be aligned. So this led me to propose that perhaps this trajectory was fine-tuned by some intelligence. And of course, this alignment will never go away, and that's why I will never rank this object lower than 2 on the Loeb scale, because there will always be this anomaly. And one should keep in mind the story about the Trojan horse, where an object looked completely harmless and then ended up being a threat to the city of Troy. So it's also possible that we would see something that looks like a comet, but then inside of it, there would be some technological gadget. And the only way for us to verify it is by detecting some artificial signal or seeing some maneuvering or finding some other signature, like, for example, the object breaks up into mini probes that visit the planets. So I asked the research team of the Galileo project that I'm leading to check for any unidentified anomalous objects in the coming months in the Earth's atmosphere. And of course, the same may happen around Mars. We have all the Mars orbiters. They may check for any new objects showing up on the Martian sky.
Wow. And again, you mentioned this before, but just would love your clarification. So early images of 3I Atlas raised eyebrows about morphology. Several images showed a compact ball of light with a sunward glow rather than a classic tail. What physical mechanism best explains that asymmetry?
Yeah, so if one looks at the best image that was published so far, which came from the Hubble telescope, it looks like the extent of the glow away from the sun was exactly the same as sideways. So there was no evidence for a tail behind the object, because it looked pretty much circular in the image, going away from the sun and going sideways, perpendicular to the direction to the sun. However, there was an extension towards the sun, and it was viewed from an angle of 10 degrees. That's where the Earth was relative to the sun object axis. So from that, one infers that there is an extension by at least a factor of 10 of the glow in the direction of the sun. We just view it edge on. And that is a remarkable anti-tail, never seen before for other comets, and needs to be explained. And the only physical explanation I could come up with was that there are fragments of ice being evaporated from the sun-facing side, and those disappear after a while, but one sees them extending to a distance of at least 10 times the characteristic region around the object that is glowing.
Wow. Thank you so much for sharing all this information for the audience that are viewing this today. And thank you so much for sitting down with me today. I'm looking forward to releasing this episode. And yeah, thank you.
Yeah, science is fun because we shouldn't pretend to know the answers in advance. And so the evidence should guide us. And, just in recent weeks, I realized that my essays on medium.com are getting millions of viewers, readers.
Oh, wow.
And that was surprising to me, how much the public cares. So I see it as an opportunity to communicate to young people. And there was even a pilot that wrote to me, a former pilot of the US Air Force. And he said, because of you, my daughter now wants to become a scientist. And I found that to be the biggest privilege, that the biggest reward that I get for my work, if I'm able to attract a fledgling scientist to pursue a scientific career. I did my job, and it doesn't really matter whether 3I Atlas is a rock or a technological object. And of course, if it turns out to be a technological object, then it will change everything. And actually, last week I wrote a white paper, submitted it to the United Nations, telling them that they should establish a new committee that would look at the future interstellar objects to decide whether they are a potential threat to humanity. And my hope is that such an organization will be established. Of course, the chance of it happening before the first encounter is small. I don't expect politicians or others, policymakers to um, really get concerned about such a threat until the first encounter. And the hope is that we will survive that encounter. And then, of course, after the first encounter, there might be a huge amount of awareness to the potential threats. So we might establish a fleet of interceptors or probes that would alert humanity to a potential threat from the outer solar system. That could come out of an investment of $1 trillion a year, which is a significant fraction of the military budgets that we have every year to space exploration. And I think this will be a natural outcome of realizing that there is a global threat. It affects all humans because we are all in the same boat.
Yeah.
And my hope is there will be a response at the level of $1 trillion a year. But before that, what we need is a copy of the Rubin Observatory that currently surveys the southern sky and will find a new interstellar object every few months in the next decade. We need a copy of that in the northern hemisphere so we can see all directions. And that would cost of order $1 billion. So it's not as much, and it will give us an alert system. So that's my hope, and that we will be alerted to any future interstellar objects that enter the inner solar system within the coming decade. And then if one of them becomes a potential threat, then it will change the future of humanity.
No, it will. And the work you're doing is truly amazing, and you're inspiring so many people. So thank you for sitting down with me today. And
thanks for having me.
Of course. Thank you.
Dr. Loeb, if we confirm the existence of aliens in our lifetime, what one change in humanity's self-understanding would you most hope to see in science, culture, and how we treat one another?
Well, that's an excellent question. In 1882, Friedrich Nietzsche suggested God is dead. And that brought humanity to the modern age of science and technology, and unfortunately also a sense of hubris, arrogance, that there is nothing more intelligent than us in the universe. And I think we desperately need a sense of modesty, humility. And of course, traditional religions provided that with the image of God being a superhuman entity that is far more powerful than us humans. But when you push that aside, the question, you start believing that we are the most powerful things in nature, and people have no regrets eating animals that are less intelligent than we are in restaurants on the menu. And
I know.
yeah. But and we are about to enter a new phase right now where we produce artificial intelligence systems that might supersede human intelligence, the cognitive abilities of humans.
Renaissance here.
Yeah, and that could bring a sense of humility and awe at something. This is like a technological kid that we produced that is smarter than us. Like I feel with my daughters sometimes that they're much better than I am. Yeah. But in this case, it's technology-based AI systems that we produce. And there is another form of AI, which is alien intelligence that we may encounter. Yes. And for example, the human brain is using up 20% of the metabolic power of the human body.
Yes.
So the human brain grew to become the biggest possible, given the amount of power that is produced by the food we eat and so forth. And when we deal with creatures or entities that are intelligent, that were made around other stars, it's possible they have bigger brains because they have bigger bodies or some other evolutionary reason. And in that case, they would be far more intelligent than we are. They have more neural connections. So just like advanced AI systems, they could already biologically be much more intelligent than we are. And there is a selection effect that those that will come to visit us before we visit them are probably more advanced than we are because we never went outside the solar system. Yeah. So if we see those that are the most accomplished students in our class of intelligent civilizations visiting us, we will get a sense of modesty. We will be filled with awe similar to religious awe of something that is more powerful than we are
Greater than
if we
us.
meet it,
Yeah.
meet it. And that's what I hope for, frankly, because I very often, when reading the news every day, I get frustrated, disappointed by what I see. It's like being in a party where the attendees of the party are misbehaving. And the only thing you can hope for is looking through the window, hoping for a guest that will change the situation. So I'm hoping that we will encounter a more advanced civilization because they will give us a better role model for how to behave.
Right.
And they would inspire us to put our priorities in a different place than just killing each other or protecting ourselves from others killing us. I mean, if you just think about where $2.4 trillion a year are allocated to military budgets, it's all about military threats, about disputes on territories, on this rock that we were born on, and the real estate that we find on this earth is really meaningless compared to how much real estate there is up there, outside in outer space. So when we realize that there are other neighbors that represent other territories, that represent more accomplishments than we currently possess, it may change our priorities. And also, we would realize that we are all in the same boat here on Earth. So we better work together. We better cooperate, because there is a neighbor out there that, could be a threat or could be an inspiration to all of us. So I think my hope is it will bring humanity to a better place where we would be more cooperative. We will look up instead of down on each other. And it will give us a sense of awe, that a sense of humility that is required for us to grow, rather than be so proud of ourselves.
I know.
Yeah.
We'll be humble.
Yeah.
It's going to be a breakthrough. And I hope it does, because it's need of the time. Because our heads are we are so much full of ourselves. I mean, including me.
Yeah.
We have to change. So we need to humble down.
There is another issue, which is that there could be existential threats on Earth, either because of self-inflicted wounds, wars or climate change or something hitting the Earth. So we better go into space and preserve part of humanity. And the solution is not to go to Mars or the moon, because Mars is just another rock with much worse conditions.
Elon Musk
it's a
would
desert.
be not happy to hear this, though.
Well, it's a desert, doesn't have an atmosphere. If you just live on the surface, your body is bombarded by cosmic rays, and your health will deteriorate within a matter of years. And why should we go to a worse place?
Heaven here.
No. So my proposal is to build a space habitat that we control, that can accommodate humans under controlled conditions. So we started in the jungles of Africa. We ended up in high rises in cities. The next step is to go from high rises in cities to space, on a space platform that accommodates people, that has perhaps artificial gravity by rotation, a spin of the spacecraft, that has all the conditions comfortable for life as we know it. But it needs to be a big platform, and it may be expensive, but if instead of investing $2.4 trillion in military budgets a year, if we invested $1 trillion in space exploration, in architects, in engineers, in scientists that will think about a space habitat, how to build it, I think by the end of this century, we should be able to do it. It's just a question of priorities. Why should we keep, firing weapons at each other rather than working together to go elsewhere within the cosmos? If we don't realize it, we deserve not to stay around as a civilization. The universe would not care about us because there were probably other civilizations that went away, they lived for a while, and then some catastrophe killed them, and we don't even know about it. The universe will continue its course. Even the Earth will recover from humanity and will continue to exist until the sun will engulf the Earth.
Yes,
And
yes,
then
yes.
the Earth would be
Yeah, the
brought to the...
dissolution of Earth, it's gonna happen. Like,
Everything
every time
changes.
it's
Everything
changing.
changes. But, it's important for us to leave a signature, leave something behind. And for that purpose, it's better if we think bigger than just engaging in conflicts with each other and just, explore space. But if we don't do it, we certainly deserve not to survive for very long, because we just were not worthy of thinking bigger.
Beautiful. And especially what you told my daughter, that we're not looking for any prizes.
No,
We're just doing it because we want to help. It's love.
exactly.
It is
Yeah,
love.
it's a work of
Unconditional.
love.
It is love.
I was asked actually just a few weeks ago for putting my essays on medium.com that I have every day or two, putting them under a paywall. And I said, no, I'm not willing to do that because it's work of love. I don't want to make money out of it and restrict the access to those. For me, I enjoy communicating with the public, enjoy the process of doing science, and it has nothing to do with making a living out of it. It's something I would do irrespective, as long as I have food. I don't need a lot. I jog every morning at sunrise.
Very pretty healthy.
Yeah, I'm trying to, yeah. And I don't care what people say. I don't have any footprint on social media. That also is important for maintaining a good health. Mental health is not paying attention to what other people are saying, just doing what sounds like the right thing. And I'm really pleased that it appeals to the public and that it resonates with a lot of people.
It has. It has. It is.
And to me, the most surprising part of my life was that I realized that, I'm just trying to say what sounds like common sense, but I realized that common sense is not common, especially in academia.
Yes.
So that's what allowed me to get tenure, to publish 1,000 scientific papers or more than that, 9 books, and get recognized. It's the fact that what I find to be simple and straightforward and common sense is not being done by other people. And that is a surprise, because how would I know if other people would not think the same way? And not only that, but some people are attacking me, which is even better, because it means that they would never be able to deny that I was the first to come up with these ideas. If they were not attacking me, they could have used these ideas and advocated these ideas themselves. So people would have forgotten that I was the first one to suggest them. But the fact that they attack me is a blessing, because then it's clear that, it was my idea. So in fact, being, advocating for things that are not necessarily popular is a blessing, because it allows me to make a useful contribution, which otherwise would not be made, and also distinguishes what I'm doing from. And what I tell young people very often is, when you go to the beach, you see all these seashells that were swept ashore, and you can tell the difference between relatively young seashells that were just swept ashore recently and those that existed for a while on the beach, because those that were for a while, they lost their color by rubbing against each other, whereas the new ones that just came on shore, they still have their unique colors. And so my advice to young people, don't rub against other people all the time, because you would lose your unique colors. And that's why social media is not good for you, because you're becoming similar to others when you are seeking approval, when you are trying to get as many likes as possible. So maintain your colors, your beautiful colors that you were born with, and not surrender to peer pressure, to what others are saying.
That's a great message for the young, and no wonder why my kids, they love you so much. It is great to have you. Thank you so much. Lovely meeting you.
Same here.